Hi, I'm Adam. Welcome back to Godot Game Lab. This is the first episode of Season 2 for the AutoBattler series. I cannot really show you a demo because there's not much to show for this one. It's more about just getting back to the groove of developing, setting up the new project, and refactoring a bunch of stuff. So to begin with, I have the GitHub repository open for the AutoBattler course. Let's click on branches. And if you want to follow along, there's a new branch called Season 2 Starter Project. Click on it, and this opens up the starter project. Go to code and download zip. And once you have extracted this zip, you are basically ready to go. I also updated the project to the latest stable version, which is Godot 4.4.1 at the time of recording. So here's a quick rundown what you can expect from this first episode. First of all, we'll separate some of the scripts because we've sort of dumped everything into the components folder, and in hindsight, it might have not been the best idea. I'll explain why in a second. Then we'll introduce a new component called SceneSpawner because after taking some time off, I realized that we have a repeating functionality which we do a couple of times, and extracting this out into its own component makes the code lighter and less redundant. Also, we have a bunch of this combination of waiting for the node to be ready with the await signal, specifically used when setting export variables. This is a technique we used extensively in the SceneSpawner course as well, and it's one thing that I've never really been 100% happy with, so I've decided to revisit this problem, and I found, I think, a more elegant solution, which I like better. Then we'll introduce a new component called pegged sprite 2D. This feels like pushing this component pattern to its absolute limits, and you'll see why when we get into it. And finally, we'll refactor the unit scene and talk a bunch about my decision to actually use two separate scenes for units, one for the preparation phase and one for the actual battling phase. So let's get started. So I have the starter project here in Godot 4.4.1. And first of all, I want to show you very quickly what new assets we have. So inside our sprites folder, I have some new PNGs for effects and projectiles. And inside this sprites folder itself, we have a new PNG for items in the future. And we also have this startbattle.png, which is an icon for a button we'll put here, which initiates the next battle. Besides sprites, we also have a bunch of new sound effects. So inside our SFX folder, we have a bunch of different sounds for Björn's auto attacks, the spellcasting, and we also have two sound effects for Robin. You could easily search for more sound effects when we actually implement this battle system, but I just wanted to include a couple ones to make the game sound a bit nicer. Okay, but for now we can collapse the assets folder. And what I want to do first is expanding the components folder. And if you take a look at this, we dumped a bunch of stuff here, right? But let's stop here for a second and think about what components are and how we use them for our game. So I said that components are a way to reuse functionality. Basically, by adding that component to whatever we want to have that functionality the component provides, right? So for example, we want to be able to drag and drop units in the game, right? So what we did is we created this very general drag and drop component. And if I press Ctrl-Shift-O and search for unit.tscn, you'll see that we just added the drag and drop component to it, set up the export variables, and it's ready to go. We can now have the drag and drop functionality inside our unit scene. So that's a perfectly valid reason to create a component because we can reuse this, right? Later on when we implement items, we also want to be able to drag and drop items. So what we'll do is we'll create the item scene and instantiate the drag and drop component to set it up in a very similar fashion. Same goes for the outline highlighter, right? We want to highlight the outline of something we are dragging and dropping or something we are hovering or anything like that. That's a completely valid component. It can be reused, and in the context of our game, it will be reused probably, right? But we do have some which are problematic, I think, in a sense that we dump them in the components folder, but we never really plan them to reuse. Can you give me an example for that? So if we go back to the arena scene and take a look at our scene tree or the hierarchy right here, we do have the unit mover, the unit spawner, and the unit combiner. We called those components, even though I highlighted that They are very different from the other components, and the reason why they are so different is because they are not really components if you think about it. Do we really want to reuse a unit combiner inside the game? Well, not really, because we only want to have one unit combiner, right? Same for the unit mover, the unit spawner. If we go back to the unit animations, it's definitely not something we want to reuse elsewhere because these are exclusively for just the unit scene. Same goes for the unit grid. I think the play area as well. Like, do we really want to have play areas in different places in the game? We have 2 of them and that's it, right? We have the gameplay area, this one, and we have the bench. Technically, we are reusing it, but calling it a component is, I think, misleading because we won't really use them elsewhere. We just use them as play areas. It's not a plug and play thing like a drag and drop component. Hopefully, you'll see this difference between the two. One is very generic and can be reused even across multiple projects or games, right? This drag and drop component or the outline highlighter could easily be used inside the Slay the Spire game or another different game we make in Godot. The same cannot really be said for the unit combiner or the unit grid, if that makes sense. But we don't really have another folder to put them. That's why I dumped them inside the components, because we only have a scenes folder, and this is used for actually saved TSCN files, which are scenes we can instantiate inside the game. But again, we don't really want to instantiate multiple unit combiners in the game, so saving them as their own TSCN makes really no sense to me, because then we still have the script, but we don't really want to instantiate them dynamically anywhere in the project. What I ended up settling on with myself, I'm not sure if that's the best solution. Honestly, folder structure is just something that has to make sense to you. But what I ended up doing inside the root folder, the resources folder, is creating a new folder. So right click on it, create a new folder. And I didn't have a much better idea, so I call this custom_nodes. Because these are custom nodes we use inside the game, but they are not really components we can reuse across different games or even inside the same game. So if we expand the components folder, I press and hold Control and select all the scripts that I think belong in this new folder. So that would be the play area, unit animations, unit combiner, unit grid, unit mover, and unit spawner. So I think these are more like custom nodes we use inside the game than reusable components in multiple projects. So with all these scripts selected, I just scroll down and drag and drop them with the left mouse button to this custom nodes folder. Now this would be something that is very dangerous to do in previous versions of Godot, but since Godot 4.4 introduced UIDs for files, which are unique identifiers, it's much safer to rename and move them inside the project now. In theory and in practice, with my limited experience, it breaks much less than it used to. So now we truly have components in our components folder which are reusable in different contexts or even in different games. And just to make sure that everything's still working fine, let's go ahead and play the game by pressing F5 or clicking on that button. And one new thing that you might notice is that in Godot 4.4 we have this new game window, which makes it possible to embed the whole game inside the editor instead of running in a separate window, which is pretty handy. One thing that might be different for you is that it might still be a separate window. And if that's the case, but you want to embed it, just click on these 3 dots right here and make sure you disable Make Game Workspace Floating on Next to Play, restart the thing, and now it will be embedded inside the editor. Cool. So now if we are inside the game, I can still buy units, the units will combine together, I can buy XP, reroll for new units. So everything's still working as expected. I can interact with the game, but we do have a couple bugs, which I believe came with the new version. Probably something has changed with GD script. So the thing you might notice is that in our label where we display the XP requirement, it says 4 out of 6.0, which is pretty weird. If I buy more XP, it will be 0 out of 20.0 or 4 out of 20.0. And this is definitely not what we want. And another problem we might have, if you take a look at Björn, the HP bar for that unit should be rendered before this Harry unit, right? And when we drag them around, it works with Robin, which seems pretty weird, but not with Harry. So we want to fix these two issues before starting any other refactoring. Let's start with the first one, this one. So if we scroll down in the scene tree, we have our shop scene, which includes this whole thing on the right. So let's click on this open in editor icon. And we have this reroll and XP tracker. And inside that, we have our XP tracker VBucks container. We scroll all the way in. You see that this is the one we want. Click on open in editor. And we have the XP label. So this is the problematic one, right? This is where we saw 99.0 instead of just 99. So let's click on the script icon for the XP tracker to open it up in the script editor. And this is the function where we set the XP bar values. So what we do is we grab the current XP requirement from the player stats resource. If we press and hold Control and click on it, you'll see that this returns an integer. So this shouldn't be a problem. So if we go back to the XP tracker, you'll see that despite it returns an integer, we store it as a float inside the new variable. And then we update the label text with those two variables. So that's the problem. Player stats.xp will be an integer, and this is the first number in the placeholder string we use. And the second number, this XP requirement variable, will be a floating point number, meaning it will have this fraction attached to the end of it. So why on earth did we store it as a float if it's clearly an integer? Well, because we want to set the progress bar value, which needs to be a float. And you'll notice that we do a division and we divide the XP we currently have with the XP requirement for the current level. And see, the problem is if for a division, both of these numbers are integers, then the result will be an integer as well. And that's not good for a progress bar value, which wants to be a floating point number between 0.0 and 1.0. Or even if it's not between 0.0 and 1.0, like in this case, the division itself needs to be a floating point number to get the ratio or the percentage we currently have. But that's an easy fix. What we can do is we can say that the XP requirement won't be a float anymore. I'll just use colon equals, which means that it will be an integer, right? And I do get a warning instantly that in line 38, I do have an integer division, which is this one. That's a valid warning because the progress bar value wouldn't work. But what we can do is we can cast this XP requirement to a float, but only do it here. So when we display it as a text, it won't be an integer anymore. So let's just change this to float XP requirement, save the script with Control S, and we should be good to go. If we play the game again, you'll see that it says 0 out of 2. And if we start to buy XP, the progress bar seems to be working because this should be around 2/3. Yeah, and it does work just fine. And now we have two integer numbers. So we fixed that issue. But we still have that issue of units having their health bars kind of rendered behind the unit on top of them, but not always. So for some reason, it works if I put Björn up, but if I put him down, it doesn't work, right? And what happens here is pretty interesting. Let me show you a cool feature we have with this new game window. Right here we have 3 buttons. One says that allow game input, which is the default one. And we can click on this 2D button, which disables interacting with the game. And instead you can select objects from the game in real time. And what's cool about this is I just click on stuff and it will show me the properties for it in the inspector and I can make changes in real time. See, the problem is I selected the collision shape, but I want to select the units themselves. But that's not a problem because we have another icon here which says show list of selectable nodes at position clicked. And if I click on this robin here, you can see I can select all of these nodes and I want to select the unit itself. Okay, so if we select this and go to the remote scene tree, you'll see it will be highlighted inside the scene tree. So we do have 3 units in the scene tree. And if we go back to input, we can still manipulate the game. And if I put Björn up and select Björn, this unit will be selected. Can you guess what the reason for this health bar issue we have here? Well, it has to do with rendering and how 2D rendering works in Godot. So if you remember, anything that's lower in the scene tree hierarchy will be rendered in front of the other one. So we have this area 2D at 11, which is this Björn unit. He is on top of this arena unit grid hierarchy. this unit and this unit will be rendered in front of him no matter what because they are lower in the tree hierarchy. The problem with these two units here is that despite the fact that this Robin is under the other one, it will be rendered behind him because in the scene tree, that sort of order is not respected, right? Because the lowest one, which will be rendered in front of the other two, is above him. So that's the problem we have. It isn't really a problem with the units themselves because they don't overlap, but it is a problem with their health bars. So how do we fix this? Let's go back to 2D view, press Ctrl-Shift-O to quick open a scene and search for unit.tscn. Let's zoom in to see what's going on a bit better. And if we only want the UI to be in front of the other units, no matter what, we can use Z indexing for that. It's a quick fix, not without its own problems or fallacies, but it will work fine for our purpose here. We want to select the health bar, press and hold Shift and click on the tier icon, so we select all three of those. And since all of those inherit from the canvas item class, we can click on ordering and change their Z index from 0 to 1. And what this does is it will render it in front of the unit visuals, because the unit visuals are canvas items as well, and their Z index will stay at 0. So if we save the unit scene with Ctrl S with this small little change and run the game again, and see, I cannot really buy units now because I have to put this allow game input back. Now I can buy a couple Robins and Björns, put them inside the game. And it seems to be working, but just to double check it, let's go to the remote scene tree, switch to 2D, and select this first Robin. Doesn't really matter that the collision shape is selected because we arrive at the scene tree where we want. And you'll see that by the rules I told you, this Robin should be rendered in front of the other one because this is the lowest in the hierarchy. But no matter what I do, where I put these units, their health bars will always be rendered in front of the other one because we changed the Z index. So that's nice. Maybe the only downside of this solution is that you can't really grab a unit. So you see, I can't really grab Robin here because the health bar of Björn blocks that interaction, but it's still pretty easy to grab them up and move them around. So I don't think that's a problem, but we'll just leave it as is for now. Okay, so these are the two minor bug fixes I wanted to do before jumping onto any further refactoring. Now, the next thing we want to do is we want to introduce a new component called SceneSpawner. Let me show you the reasoning why I think we need it. If we go to the script tab, we have whatever script open here. Let's press Ctrl-Shift-F to find in files and search for instantiate. And if you search for instantiate, you'll see that we have three different places where we call this instantiate method, which is used to instantiate packed scenes. We have the traits UI, we have the shop UI, and we have the unit spawner. And if we click on these, hide the search results for now, what do? We have a constant called unit, which if I scroll up is a preloaded scene, right? A packed scene. We instantiate it, add it as a child, and do whatever it is that we want to do with it. If we click on the search results, go to a different one for the unit card, what do we do here? Well, we have a constant with all caps, which is a preloaded scene. Then we instantiate it, add it as a child, and do whatever it is we wanted to do with it. Now, if we go to the last one, you can guess probably what happens. We have a constant with a preloaded scene, and we want to instantiate it, add it as a child, and do whatever it is that we want to do with it after, right? You'll see a repeating pattern here. And it's not a problem, strictly saying, like it's 3 or 4 lines of code, but we do it so many times throughout the project, especially with the new functionality that we'll be adding, that it might be a good idea to actually create a separate component for this. So that's what we're going to do next. We'll create this new SceneSpawner component and we'll refactor all 3 of these scripts where we used this technique. So let's go to our components folder in the file system tab and expand it, right click on it, create a new script, and we'll call it scene_spawner.gd. Click on create and double click to open it up in the script editor. And this will be a pretty simple component and one that you can actually use throughout all your Godot projects if you wanted to. So what we do is we'll provide a custom class name called SceneSpawner and also an export variable called the scene, which is the scene we want to instantiate with this. It will be a packed scene. And we'll provide one single function called spawn scene, where we do have to provide one data, which is the parent for that newly spawned scene. So we can optionally set the parent of this newly spawned scene inside the scene tree. It will be a node, and this equals owner means that it's an optional input parameter. And if we don't provide it, we'll use the SceneSpawner component's owner as the parent for that newly spawned scene. Which means, if you think about it, that the SceneSpawner by default will spawn the new scene inside the scene tree as a sibling, right? Also, very importantly, we return that newly spawned scene from this function. So if the owner of the component wants to do something else with the node after adding it to the scene tree, they can. The function itself is super simple. We'll instantiate the scene just like we did previously in all the different places, store it inside a variable, call the parent's addChild method and pass in that newly instantiated scene, and return the new scene when we're done. And that's it. Pretty simple. Actually, if we want to create a more sophisticated scene spawner, there's a bunch of stuff you can add to this. So for example, if you make a game where you are spawning a bunch of enemies and you want to select them randomly from a pool, you could create another function called spawn random scene, and the export variable wouldn't be just packed scene, but it would be an array of packed scenes. And this component could pick randomly between those packed scenes and instantiate one of those. So there are a bunch of ways you can spice this up or make it more practical for your use cases, but for this project, this is more than enough. So let's save the script with Ctrl S, and let's start refactoring all those other places. So if we go back to 2D view, go back to the arena scene, we do have our unit spawner, which used to spawn units on its own, but now we can rely on the scene spawner component. So with the unit spawner selected, click on the plus sign or press Ctrl A and search for scene spawner. Add a new scene spawner, and you'll see that we have an export variable for the packed scene we want to use. Click on the arrow, quick load, and search for unit.tscn because we do want to spawn units with the scene spawner. And now if we open the script for the unit spawner custom node we have, first of all, let's scroll up because we no longer need that constant, we just set it as an export variable, right? What we do need is a reference to our scene spawner component, and we can do an already variable reference since we'll know that we have this child node. And then if we scroll down, this is where we used to do instantiation by ourselves. And now what we can do instead, this line, is just call the unit spawner's spawn scene method. And since we added this to the first available areas unit grid, we can just pass the gameplay areas unit grid as a parent, as an owner to this spawn scene method. So this will return a node to us, and we can't really be more specific in the scene spawner component than a node because this can be used for all kinds of nodes or scenes, right? So we'll have to do this typecasting by ourselves, but since we know that the scene spawner will spawn unit instances, we can just cast it to a unit with as unit. And this is handy because if we were to write more code here with a new unit, we'll get auto completion. So if I start typing new unit dot, I get access to all the properties and methods and signals we have because we casted it to a unit. Okay, so now we don't really need to add it as a child ourselves because the scene spawner component will take care of this, right? So that's the line we can also get rid of. And this should be good to go. So let's save the script with Ctrl S. Again, double check. This is the line we changed. And also we removed one line of code from here. We added an already variable reference, and we also got rid of the constant we had. Now let's play the game and see if it works. If everything's fine, I should still be able to spawn units when I click on them inside the shop. And I do. So we didn't break anything, we don't have any error messages, so far so good. Now the next one would be either the unit card or the trait UI. Also, if we bring up the search results, you can always click on refresh And you'll see that we still have 3 matches, but only because the SceneSpawner is added, the unit spawner custom node is no longer here. So let's click on the shop next. The method will be pretty much the same. Scroll all the way up. We can get rid of the constant we had. Then we can add an already variable reference to the card spawner. But mind you that I haven't really added it to the scene tree yet, so let's not forget to do that after fixing the code. But now in theory we should have a scene spawner. So if we scroll all the way down here when we roll for units, again, let's examine the code. And what we want to do is we want to, instead of this instantiation by hand, we want to call the card spawner's spawn scene method. And this time we want to use the shop cards as the new parent because we have this line of code here, which we no longer need, but you see that we use the shop cards container as the parent, but we no longer need to add this child node by hand because the scene spawner will take care of this. And again, we can just make sure that we cast it to the correct type. So with these lines of code, we would have auto completion, right? So this should be good to go. Let's save the script with Control S, but let's not forget that we haven't added that scene spawner component yet. So let's go back to 2D view, press Ctrl Shift O, search for shop.tscn, and with the shop selected, let's click on the plus sign or press Ctrl A, add a scene spawner, click on create, and again we can click on the arrow and quick load the pegged scene we want, and this time it will be unit underscore card. That's the scene we used to spawn, and if we save that scene, now we have this component attached, and the script should be good to go because we referenced this scene spawner with a $sign as an already variable. Again, let's make sure that it works. Run the game and test it. But if we reroll, we should see new, let me buy some XP, we should see new units and no error messages. Cool. So the final thing we want to do, let's go back to the search results, refresh. And now we only have the trait UI or the trait system. Click on this search result and do the usual business. Scroll all the way up, get rid of the constant because we no longer need it. But we do need an already variable reference to the trait UI spawner, which we don't have yet, but we'll add it later on. And if we scroll down, we have our create trait UI method. This is the line where we have the error message. Let's replace this with trait UI spawner.spawn scene. This time, the parent will be the trait container, as we can read it from here. This is what we used to do. We no longer need that add child call. Delete this and also typecast it as a trait UI so we have auto completion again. Save this with Ctrl S, go back to 2D view, press Ctrl Shift O to quick open a scene and search for traits.tscn. And here we need to add a scene spawner too. Press Ctrl A or click on the plus sign. Scene spawner is fine. And the scene we'll be using, click on the arrow and quick load trait underscore UI. Save the scene with Ctrl S, and now if I click on the script, we should be good to go because this is the script we're editing, and this is the already variable reference we make, and we do have a scene spawner here. If we go ahead and play the game one last time, the trait UI should still work, and it does spawn and delete those trait UIs. Awesome. So now we have this scene spawner component ready to go and built inside the game. And in the future, if we develop new features and we want to do scene instantiation, we always know that we can use this component just by attaching it to whatever it is we want to attach it to. If you like my content, please consider checking out my Ko-fi page where you can donate one time or become a member and get early access to all my content and videos. Now, the next thing I want to deal with is this await ready. So if we press Ctrl Shift F again and search for await, you'll see that we have 4 awaits inside our project. If we click on either one of these, they're really used for the same purpose. So if I collapse the search results for now, we have this tier icon and we have an export variable called stats, which is a unit stats resource. And when we set it, we call this setter function. And here what we do is we have an if statement and check whether the node is ready in the scene tree or not. And if it's not ready yet, then we await for the ready signal to be emitted before continuing with the execution of the setter function. And while this works, I still don't really like it for some reason. I just want to avoid using coroutines and await whenever I can, because in my opinion, Godot provides a cleaner way to do things with the signal system. and one-time connections, because await does have its own problems, and I don't know if it's really clean to do waiting for something when we just want to set a variable, right? It's a bit weird at best, but it does make sense because setter functions will be called even before the node is ready in the scene tree. So we did have problems with that in the past, both in the SceneSpawner course and in this one. And the reason why, if we take a look at this piece of the documentation here, is because most of the operations will be done from top to bottom, as you see with this arrow. So drawing 2D, processing or getting notifications, you'll see it's done from top to bottom. That's the reason why we had that Z index ordering issue. But see, an important exception is the ready function, which is done in the exact opposite order. So what we do is we wait for the ready notification from all the child nodes before actually this panel emitting that it's ready. It says that each parent node has its ready function called only after all its child nodes have their ready functions called, so that the parent knows its children are completely ready to be accessed. So it says that in the above image, name label would be notified first, followed by name, etc., and panel would be notified last. So that's the info we want to rely on when actually avoid using this await. By the way, if you're fine with using this await, there's no real downside that I know of. It's been bothering me because I don't really like this solution. And I stumbled upon this thread from the Godot forums, and I really like this answer here, which says that export variables are set immediately when the scene is instantiated, but before the ready function is processed. So you're simply going to need to assume that anything can be null and then make a ready function that does the setting, right? And what they do is inside that setter function, instead of waiting for the ready, just simply check that if the instance they want to use is valid or not. And if it's not valid, they can return from this function. And I find this much more clean as opposed to waiting for the ready signal. But again, this is just a personal pet peeve of mine, and I thought it's worth talking about and maybe discuss this. But if you don't want to change this, then you don't have to. And I feel like I started putting this in without giving it too much thought, because if we bring up the search results and look for another one like the unit, here it clearly can be a problem that the node is not ready inside the scene tree. Why? Well, because whenever this setter function is called, we want to change the skin and the tier icon, child nodes. And hopefully you see the problem. This unit node is above them, right? We have tier icon here and we have skin here. Both are child nodes. So we can't be sure that they are ready inside the scene tree when this setter function on the unit is called, because it's for sure that the unit will not be ready yet when this is called first. So here we do have a problem, because if this node is not ready and we want to change something in the skin and the tier icon, both of these references that we use here as already variables can be null. And the reason why is that because so here it's a problem because we want to access a child node. But if we go back to the tier icon and see what we do here, we just want to connect to a resources signal. So here I don't think this would cause any problems that the node is not ready inside the scene tree, because we don't really try to access any child nodes, right? We just want to set the texture, which is a property of this node itself, which does have this script attached to it. I think it's superfluous to do this in the first place. So let's simplify this tier icon for a bit. We can get rid of this one. Okay, so we can save this with Control S and we should be good to go. So if we play the game, buy some units, yeah, the tier icon works. And if I buy Robin, yes, it's updated as well. So we didn't really break anything. And one thing I always vouch for is being able to test scenes independently. So that should work too. If we go back to 2D view and search for tier icon.tscn, you'll see that we have our icon here. And if we run the scene, we do have that icon there. And while the scene is running, we can change this to bjorn.tres. And if we change it, nothing happens because this resource does have the tier 1 attached to it by default. But if I change it to 2, you see that it immediately updates, right? If I change these values, if I remove the stats to become empty, then it still works. So we still didn't lose that functionality of testing that tier icon separately outside of any context, everything works as intended. If I were to double click on this burn resource, change the tier to 2, assign it to the tier icon by dragging it over, it won't update inside the editor because it's not a tool script, but if we run the scene again, it should display that 2-star icon. And it does. So again, if I change it, it works. So we didn't lose any functionality, and in this case, it was rather superfluous to include it in the first place. Okay, so I set it back to tier 1, everything works fine for the tier icon. Let's go back to the script tab and look up the search results. Now we refresh, one await is gone. Let's do the unit next. Or you know what, let's leave the unit for last because we want to refactor it anyway. So let's go to the unit card instead. Now here, what do? We set the unit stats resource and we do a bunch of stuff here, which I assume are child nodes. But just to double check, let's press Ctrl-Shift-O and search for unit card.tscn. And we do have traits.txt and traits is a child node. So now we do have this problem if we just delete this await from here and press Ctrl-S to save it. Now we should have this problem if we go back to 2D view and the unit card unit stats resource is set to Arthur, and if we run the scene, we do have an error message. So that's why we included this await. So what happened here again is that we run the scene, we set the export variable for the unit stats, and this is called before the unit card is ready in the scene tree. Which means that if we take a look at all these onReady variable references, they are all null, right? Because we have onReady references, and onReady means that this variable will only be set when the unit card is ready in the scene tree. So that's the problem we have by deleting this. So how can we fix it? Well, it's pretty simple. We just have to check if all the nodes are valid. But how do we make sure that everything is valid? Well, if you remember, the order is this. The backdrop will be ready first, then the bottom, then the border, then the unit icon, then the empty placeholder, and just after that, the unit card will be ready. So what we can do instead is just say that if the empty placeholder, which is the last child node here, is not valid, then we can return from this function, and we don't have to do any of these because we try to do it before this unit card is ready in the scene tree. And including this line eliminates the use of coroutines. And if we run the game again, we do have a running scene without any error messages. But the problem is that we don't really update anything, right? Because Arthur should be purple and all that stuff. We do have this problem that, okay, we skip the thing, but we don't actually update it. So what we can do is when the scene is running, we just drag it over again, and now it works. The only minor setback of using this version is that you can't really test right away by having this assigned. But what you can do if you want to test it is just call this method from the ready callback, right? So for testing purposes, you can do this, but you don't really have to. I think it's just in the new versions, it's completely fine for me to just redrag this and test if it works or not, right? That's not that big of a deal. If you want to make this automatic, then you can just do a call to this setter function inside the ready callback. That's what the fellow developer in the forum thread also suggested, that you call this manually inside the ready. But this is only needed if you want to test this, and I'll show you why. So if we run the scene now, we should have Arthur like automatically updated as well, right? So you don't really lose that functionality, you just have to include it by hand inside the ready. The reason why we don't really need to do this other than testing is if we think about when we use the unit cards, we use that inside the shop, right? So if we go to the shop script, when we roll for units, we instantiate or spawn a new card. We do it with this new component we have. And then after adding it under the shop cards container, we set the unit stats property. So this line will call the setter function. And since our SceneSpawner will add it to the parent, it will be ready inside the scene tree. So by the time we set the unit stats parameter or property of it, the setter function inside our unit card will be called, and we don't have to do it inside the ready again, right? Because that would mean that we actually call it twice. And we don't really have to do it, so we can just delete this. I just wanted to show you that we can still have that functionality of running the scene and automatically showing the update. But if you don't mind changing it, we can just drag and drop it like this. Okay, cool. So now we sort of got rid of 2 awaits, and we do have one in the trait UI as well. Basically, whether you need that is instance valid or not depends on whether you want to access any child nodes inside that setter or not. Because again, for the tier icon, we don't even have child nodes. So in this case, we don't really need to test this, but inside the trait UI, we call this set trait data. And I suspect that this trait icon and trait label references are child nodes. And indeed they are, right? They are already variable references. So again, we do have this problem here. Just press Ctrl+Shift-O and search for trait UI. And you'll see that trait label is probably the last node that will be ready before we can access it. And we can get rid of this line, set the trait data, and we can actually return in 2 cases. If the value is set is null, then we don't really have to do anything regardless of where we are with the scene tree. But if it's not null and the trait label is not a valid instance yet, we also need to return to make sure that we don't have that error message. And that should do it. So now if we go to 2D view, look at this trait UI scene, and we do have this elf.tares attached, run the scene. You see that it won't update, it should say elf for the same reason that we had. So if we search for elf in the file system and drag and drop it over, it will update. If we search for, I don't know, wizard, drag and drop it over, it will update, right? So we can still test it. It's just that it won't be automatically tested if we have this trait data. Also, if I set it to empty, we shouldn't have an error because we said that if it's null, we shouldn't be doing anything, and no error messages. So we are good to go. Awesome. So now if we look at the search results, then we only have 1 await inside our unit script. But unit will be its own topic. So we have to do a bunch of refactoring with the units to prepare for splitting the regular units, the preparation units, and the battle units from each other. So that's the final thing we want to do in this episode. Now let's jump onto the final part, which is about talking units versus battle units, which I ended up doing inside this course. Why this decision? Why do we separate it when we can clearly say that all of these are units, right? Whether they are battling or not. Let's look at these components with the unit scene open. Do we need drag and drop for battling? No. Velocity-based rotation? No. Outline highlighter? No. Unit animations? No. So we already have 4 components that we don't need for battling units. And it's true vice versa. So the battle units will have a bunch of components attached to them which are not needed for the preparation phase units. If we open up the script for the unit, we'll see that we have this signal for quick selling units. Again, quick selling logic inside the input callback is not needed for battles, right? Drag and drop connecting to the drag and drop signals, again, not needed for the units. Mouse entering, drag canceling, all that stuff we handle here is useless, basically, for battling units. And while this could be done inside the same class, let's look at the pros and cons of separating it out completely to a different scene called battle unit. So on the left hand side, we have the cons for using the same unit class for both cases. The first problem I ran into is when ending the battle, right? So when a unit dies, we want to delete it with Q3 or whatever. The battle ends when we deleted all of the units. What happens if the player loses? All of the unit instances will be deleted, but then they need to be resurrected for the preparation phase, right? Because we don't permanently lose our units in this game. A unit dying is only true for that course of the battle. That's problematic. Then again, we have a lot of different components attached to the same scene, which in itself is not a problem. This is a component-based approach, but the problem is managing them within the same class. So this class is pretty big now, but it would become very, very, very big if we wanted to handle all the logic for all the components, both during the preparation phase and during the battle. And I think this approach is more error prone by its nature, right? So what I can do is, if I recognize that a battle starts, I turn off the drag and drop component, I turn off the quick selling mechanic, I turn off the outline highlighter, and so on. Again, I have to do this the other way around too. When a battle is finished, I have to turn off all the ability management, the pathfinding, etc., right? So this, I think, is more error prone or more likely that you run into some bugs because you forgot to turn off one of those components and now the game behaves in an unexpected way. When in reality, these two functionalities or these two use cases for the units are very, very distinctively different from each other, right? They don't really share any characteristics besides the fact that they are both units and they use a sprite. They have health bar displayed and some stuff like that, but the business logic, the most important parts, are really different from each other. On the right hand side, you can see probably the only con I can think of when separating these units out from each other is a slight redundancy, because we have some repeating of the code, but not much, right? Both of these have to have an export variable for the unit stats resource, and they have to have a sprite or a skin which updates according to the unit stats resource, so we display the right unit. But that's about it, and even that can be reduced to the minimum by using components which do their job regardless what they are attached into. Now let's look at the pros of using either approach. So for the one big unit class approach, probably the biggest pro is no redundancy. So you don't have repeating code because you only have one big class, right? Another one which is not that big a deal with either of these, but I guess you can say that it's a bit better, is that when something's wrong with the unit, you know you have to open up your unit class, right? Because that's the only place where you can look. While in the other case, you have two different units and you have to decide which one's wrong. But again, they are so clearly separated from each other that I don't think that this is an issue at all. On the other hand, using battle units and units separately from each other has the pro of having this clear separation of concerns, right? So when you want to add something to the battle mechanics, you know where to look and where to implement it. You don't really have to deal with this turning on and off components that you don't need for that phase of the game, because battle units only exist inside the battle and regular units only exist inside the preparation phase, which yields much less code and I think is less error prone because you don't have to deal with that stuff, right? And this problem of killing units when they are dead is no longer a problem, right? Because you can just hide the regular units when a battle begins, spawn battle units at the same position, and then it becomes much easier to recognize when all of them are dead. You don't really have to do anything with the preparation units other than unhiding them, right? So that problem of whether you can delete the units or not, or you have to resurrect them when you use one unit for everything, becomes trivial to solve when they are separated. Also, you're working with fewer components at a time because battle units will only have the battle stuff attached and preparation units will only have the preparation stuff attached. So after considering both sides, I really like this solution. And just to give you an example where you can find something similar in gamedev, oftentimes when you do cutscenes in games, what they do is they just hide the player character and they have a replica of the player character, a different scene or object, which is used for the cutscene. And it's a clever solution because it's not costly to create this replica, but you don't have to worry about that replica unit running gameplay logic like moving the character or stuff like that, right? So this is a technique that is sometimes very useful to have, and I think for this game it's a clear win in favor of separating them. Okay, but how do we do this separation? What we need to examine is which parts will be shared between the two, right? So the script for the unit is definitely just for the unit because we have quick selling stuff and drag and dropping stuff. So we don't really have to do anything with this in terms of reusability. What we do need to consider is the visuals for the unit, right? So for the visuals, we do want to have them for the battle units as well, and the same is true for the health bar and the mana bars. And these are not their own scenes as of yet, as you see that there's no icon like for the tier icon for them. So let's start by saving the health bar and the mana bar as their own scenes. So then it will be reusable for the battle unit. Let's right click on the health bar, click on save branch as scene, go to our scenes folder, create a new folder by clicking on this plus icon here. Let's call it health_bar, and healthbar.tscn is perfectly fine. We can reset the position, but I find that with GUI nodes, this doesn't really do anything because if we open it in the editor and go to layout and transform, you'll see that the position will be the same. If we want to, we can reset it. Doesn't really matter because then it will be at the right place for the battle unit as well later on. Right click on the mana bar as well, do the same, save branch as scene, go up one folder, create a new folder, call it mana bar, and manabar.tscn is fine. Click on save. And now we can reuse all three of these across both the unit and the battle unit. Now, the more problematic one is the visuals, because we don't really have any way to reuse them yet. It's handled inside our unit as of now, right? This setter function, when we set the stats, it calculates the offset for the texture we have based on the skin coordinates vector and sets the position. It also has this await ready. So we have to do a bit of a refactoring here. And what I ended up doing for the reference project, which is a bit of a push, I admit, is creating another component. I just kind of wanted to show you the power of thinking in components, even though you might argue that this component is not that useful and it just overcomplicates things. What do I mean by that? I created a new component. So let's do this and then you'll decide for yourself whether you'll like it or not. Right click on the components folder, create a new script, and I call this pegged sprite 2D. And the reason why we can reuse this is because the items which will be added in the second half of this season are also exported into one Atlas texture. I figured we might have a resource for the items later, and to make sure that we don't have to count the coordinates, we can use a similar system that we use for units. So if we search for Björn, you'll see that the skin coordinates are 1 and 3. And if we search for rogues.png, you'll see that 1 and 3 means 0, 1, 0, 1, 2, 3, right? So instead of having to calculate this by hand, which would be 32 by 96 in this case, right? Because we have to multiply this with the tile size, which is 32 by 32. I figured we can do a component which does this for us. Again, doesn't really matter that much, but it's a fun way to practice components. So what does this pegged sprite 2D will do? So this will be a tool script, meaning that we can run it inside the editor to immediately see how affecting the coordinate changes the sprite. The class name will be pegged sprite2d, and we'll have an export variable called coordinates, which will be a vector 2i, meaning that 2 coordinates with 2 integers. And then we have this inline setter function provided just so we can practice it the other way around. Usually we do a setter function separately, but since this class only has this one export variable and this one setter function, I think the inline setter function looks fine here. And basically we extract out that functionality of setting the coordinates and then set the sprite's region rect position according to these new coordinates multiplied by the cell size for the arena, which is 32 by 32. We need to convert this to a vector 2 because we start with a vector 2i, but positions use floating points. Okay, so that's basically it. We can save this component with Ctrl S. And if we go back to 2D view for the units, we can change the skin to be this type. So we can just drag and drop our pegged sprite 2D on it. And now we have this coordinates export variable. And if we start to change this, since this is a tool script, you'll see it update inside the editor itself, right? Pretty cool. So now that we have this, we can update the units script as well. And if we scroll all the way up, we have our skin here, and it's an already variable reference, which is fine, but it's no longer a sprite 2D. We updated it to become pegged sprite 2D, right? And what we can do with it is when we set the stats for the unit inside this setter function, we can just say that this skin coordinates should be equal to the skin coordinates we have in the new stats. So we no longer have to do this multiplication by hand. We can just update it and the pegged sprite 2D will handle it themselves. Now the problem is that we have this await still happening here, right? And I wanted to get rid of this. So out of these nodes, the last one we'll be interested in to be ready is the tier icon. So we don't really need this anymore. We can just delete it and say that if the value is null or it's not true that the tier icon instance is valid, we can return from the function because we cannot really update the skin coordinates, right? So that's all we really need to do here. Save this with Ctrl S. And since this is a tool script as well, we don't even have to run the scene to test it. We can just select the unit and change it to, I don't know, Arthur. Just drag and drop it over, and it should update because both this and this is a tool script, and you'll see that the coordinates update even inside the editor, but just to make sure we can run the scene. And since we have a drag and drop component, we can drag it around, and if we select the unit, go back to the game tab, and search for Björn because I believe it was Björn to begin with. You can just drag and drop Björn and it should update. Awesome. So let's stop the game, save the scene with Control S, and now we have all the functionality we need for the battle unit separated out. And just to make sure, run the game one more time and see if everything works as it has before. I can still buy units, I can move them around, I can drag them in. Don't see any issues whatsoever. Cool, so I guess that's it for this video and I'll see you in the next one. Bye bye.